Explain the decorator design pattern. The decorator design pattern is a structural design pattern that allows you to add new functionality to an object without modifying its original code. This pattern is extremely powerful when you want to extend the behavior of objects in a flexible way and avoid creating multiple subclasses. In simple words, decorator lets you wrap an object inside another object to add extra features. Instead of using inheritance to add new capabilities, the decorator pattern uses composition. You take an existing object, wrap it with another object, and the wrapper adds new behavior before or after calling the original method. Now let's understand this with a practical demonstration that makes the concept crystal clear. We will build a simple coffee system where a base coffee can be enhanced with extra features such as milk, sugar, and whipped cream using decorators. This example shows exactly how decorator adds behavior dynamically without modifying the base object. We begin by creating an interface called coffee. This interface declares two methods, getDescription and getCost. Next, we create a base implementation called simpleCoffee. It returns simple coffee as its description and the cost is 50 rupees. This is the object that we will decorate later. Now comes the key part, the coffee decorator class. Coffee decorator implements coffee and has a protected field that holds a coffee object. The constructor accepts a coffee object and stores it. The getDescription method and getCost method simply call the same methods on the wrapped coffee object. This coffee decorator is the base decorator that allows us to add more decorators later. Now we create milk decorator that extends coffee decorator. Inside getDescription we add milk. Inside getCost we add 10 rupees to the existing cost. Note that we are using decorator to add milk and cost to the existing values. Next we create sugar decorator which adds aldehyde and sugar to the description and adds 5 rupees to the cost. Now let's walk through the main method. We first create simple coffee and print the description and cost if we run this program. The output will be simple coffee equals 50.0. Next we decorate simple coffee with milk decorator. We pass new simple coffee to milk decorator's constructor. Let's run the program. Now the description becomes simple coffee milk and the cost becomes 60 rupees. Finally we chain decorators. We wrap simple coffee with milk decorator and then wrap that with sugar decorator. This means sugar is added on top of milk. Let's run the program. You can see the description becomes simple coffee, milk, sugar, and the final cost becomes 65 rupees. This output clearly demonstrates how decorators can be applied one after another to extend behavior dynamically without modifying the simple coffee class. Now let's see. When should you use the decorator pattern? Use the decorator pattern when you want to add extra features to an object but do not want to modify the original class. Use it when you need different combinations of additional behavior at runtime. Use it when subclassing would create too many classes. For example, coffee with milk and sugar, coffee with whipped cream, coffee with milk, sugar, cream, and so on. Decorator avoids this explosion of subclasses and gives you a clean way to assemble features just by wrapping objects. Why is decorator important? Decorator promotes flexibility. You can add behavior dynamically at runtime based on conditions. It promotes composition over inheritance, which avoids deep inheritance trees. It keeps the base class clean while allowing you to add unlimited enhancements without touching the original code. In real projects, decorator is used in Java I/O streams, servlet filters, Spring framework components, Logger frameworks, UI frameworks, and many more places. Here is the final answer you can confidently speak in your interview. The decorator design pattern is a structural pattern that allows you to enhance an object by wrapping it inside another object without modifying the original class. It adds behavior dynamically, supports combinations of features, and prevents the explosion of subclasses. It is widely used whenever you need flexible, runtime configurable object enhancements. That is the complete explanation of the decorator design pattern.